ಕೆಳಗಡೆ ಮಡಗಮ್ಮ Please confirm whether my voice is clear or not. Audible? In the last class, we have seen exception handling. What is the need of exception handling? What are the types of exception? How to handle them? And what are errors? And how to handle them? All those things we have seen. Next topic is typecasting. Typecasting. What is typecasting? Typecasting. A simple definition: converting from one data type to another data type. Converting one data type to another data type. We have two types of casting. Two types of casting. Primitive casting and reference casting. First one is primitive casting. Second one is reference casting. Primitive casting and derived casting. Reference or derived. Primitive casting and derived casting. We know what are all the primitive data types. In Java, we have 8 primitive data types. 8 primitives. 8 primitive data types. Eight primitive data types. What are all those? Byte chart, int, long float, double, character, and boolean. These are all the 8 primitive data types. Now we are going to see casting in case of primitive data types, that too number type of primitive data types. Number type of primitive data types. Number type. There are 6 number type of primitive data types available. If we compare all these things, from shorter range to the larger range, Byte is having the shorter range comparing all of number type of primitive data types. Short is having larger range compared to byte. Short is having larger range compared to byte. Int is having larger range compared to short. Long has larger range compared to int. Float has larger range compared to long. Double has larger range compared to all of these things. Float, long, int, short, byte. Byte is the shortest range. Double is the largest range. Byte is in the shortest range. Double is in the largest range. You can check out what is the ranges in case of data types. What is the range of this number type of data types? Exact range you can find out. But what's important here is comparison. Which one is smaller? Which one is larger? Observe this program. Int I is equal to 10. Int I is equal to 10. Double D is equal to I. We are supplying primitive variable int I to the primitive double variable D. We are supplying I to D. I is what type? Int type. D is what type? Double type. Which one is having the larger range? Double. Double is having the larger range compared to int. If you are supplying, if you are trying to supply smaller range to the larger range. I is the smaller range, D is the larger range. In case of equal to, always remember it is left side assignment. I is assigning with the D. I value we are trying to supply to D. I is int type, D is double type. What happens internally? Auto upcasting. Compiler only. Compiler only does the auto upcasting. What happens? Whatever the value we are trying to supply, 10. Whenever we are trying to supply that 10, to the D. D is what type? Double type. That 10 is going to be converted or auto upcasted to the double type. 10 becomes 10.0. 10 becomes 10.0 because of auto upcasting internally. We are trying to supply smaller range type of I to the larger range type of D. Possible auto casting. Think of casting like this. Int. Consider it is a half-liter water can bottle, completely filled. Water is there, half-liter. Double. Consider 1 liter of can, empty. Double capacity is 1 liter. Consider like that. If you are supplying that half-liter water can bottle water to the 1 liter water can bottle, what happens? That half-liter water can be easily you can able to supply to that 1 liter water can bottle. Even you will get half-liter empty in that. That means fully compatible. You can able to store that half-liter water inside 1 liter water can bottle. No problem at all. Fully compatible. So there won't be any wastage. So compiler, what it does internally, it is going to upcast. It is going to upcast the value 10 to the double type. Auto upcasting. 10 is going to become 10.0. That is how we represent the double values. If you try to print a D, what you will get 10.0. If you try to print I, you will get 10. Whenever you tried to supply this I to D, what happens? Internally I contains 10. That 10 is going to become 10.0 when you are trying to supply I to D. Auto upcasting. That is internally done by the compiler itself. Compiler doesn't worry about anything. Successfully it is going to auto upcast to the double type. byte b is equal to 10, int I is equal to auto casting byte is going to be auto upcasted to int. Byte is having the smaller range compared to int. Int is having the larger range compared to byte. So smaller range data type will be automatically upcasted to the larger range data type. Auto upcasting happens. What happens here when you are trying to supply byte value to the int? Byte is going to first convert into int, then it is going to supply to I. Byte is going to convert into int value, upcasting. Then that value is supplied to I, int, auto upcasting. Compiler only does syntactically proper. You can run also. Short is having the minimum range, double is having the maximum range. In this case, short is the minimum, double is the larger. Short is having the shortest range, not shortest range. Which one is having the shortest range? Byte. Byte is having the smallest range comparing all of the number type of primitive data types. Short is greater than byte. Short is having the largest range comparing to byte. But in this case, double is having the largest range comparing to short. I we are supplying to D. Fully compatible, no issues at all. Short can be supplied to double type, fully compatible. So compiler only does the auto upcasting. Auto upcasting at line number 6. At line number 6, auto upcasting. Compiler only does the auto upcasting for you. First, it is going to convert to double. Short is going to first convert it to double. Then only that value is applying to D. Syntactically proper. Trying to convert into data type to the float. Float is having the larger range compared to int. Float is having the largest range comparing to int. What happens here? I'm trying to supply I to the F, left side assignment. First, I is going to convert to the float. I is going to convert to the float. Then only That I value is going to supply to F. So what it becomes? 20.0. 20.0. 20.0. See, there is a difference between float and double. Don't get the confusion. But both the values, generally, we are going to represent it by using decimal points. But to be specific, you want to be specific. This is float value only, this is double value only, like that. After the decimal value, you need to keep it in case if you are representing float, either in the lower case of F or in the upper case F. For example, float F1 is equal to, if you want to specifically represent float value, go like this, 10.0, either in the smaller case F or in the upper case F. That is how we are going to differentiate between double value and float value. See what happens here, carefully observe. If you simply say 10.0, you are trying to supply double value to float. Okay. Generally, you simply say 10.0 decimal value, it is not going to consider it as a float value. It is going to consider it as a double value. Double value you are trying to supply to float. Not compatible. Double is larger range. Float is what? Smaller range. What happens if you are trying to fill a water bottle? Assume half-liter water can is there, that is empty, and 1 liter water can is there, that is full. If you are trying to fill that half-liter water can with 1 liter, what happens? Another half-liter will go waste. So it is not compatible. See, simply if you say 10.0, it comes under double value, not float value. Specifically, if you want to represent it as a float, either in the small case F or capital F, then compiler knows that specifically you are trying to supply the float value. So it is compatible. Trying to supply float value to float only. And another case, if you say double d1 is equal to 10.0. Okay, what happens here? by default, this type of value, this type of decimal value is going to be considered as double value by default. Still, if you want to represent specifically, go for smaller case d or upper case d. Then exactly you are saying that I'm trying to supply the double value only. But if we say like this, what happens? Float value. You are trying to supply float value. Fully compatible. Float is going to be fully compatible with a double. Comparing to double, float is having the shorter range. Shorter range value, you are trying to supply to larger range. Fully compatible. No issues at all. But vice versa is not possible. Otherwise not possible. Double value you cannot supply to float. That is not possible. So here what happens? Float is having a larger range compared to int. Fully compatible. Int value we can able to supply to float. Fully compatible. No issues at all. Syntactically proper. Observe this one. In the main method, int I is equal to 100. So we are calling a test method that is static by supplying I value. So what is I value? 100. What is that type? I is what type? Int type. Now test method argument. It is double type. Test method argument is what? Double type. Double T. Now what happens? Upcasting is going to happen. Int is going to upcasting to the double type. Int will be upcasted to double type, then only it is going to supply the value. That means 100 becomes 100.0. Upcasting, auto upcasting. 100 becomes 100.0, then only it is going to supply that value to the test method. Auto upcasting. We don't need to worry about auto upcasting because that will be taken care internally by the compiler itself. You don't have to worry about that. Syntactically proper. We know very well if we are calling any method inside the SOP, we will get the return value. Return value. In this case, what happens? Int I is equal to 10. The test method, we are going to declare and initialize a int value. But carefully observe, test method return type is what type? Double type, not the int type. It is the double type. When you are returning I, it is going to upcast the double. 10 becomes 10.0. Then only it is going to supply that value to the test method as a return value. So if you are calling test method inside the SOP to print the return value, we will get 10.0, not 10. So 10.0 because of auto upcasting. byte b is equal to 10. We are calling test method by supplying byte value. So here supplying is byte value and accepting also byte value argument. Supplying is also byte value, argument also byte value. While returning, what we are returning? Byte value. But here return type of the test method is what? Int type. So byte is going to upcast. Byte is going to be upcasted to int type. Byte is going to be upcasted to int type. If you are trying to print the return value of test, you will get 10. Okay. You don't get 10.0 because these are non-decimal values. Byte, int, short, long. All these are non-decimal values. You will be having ranges. Observe in this case what happens, where upcasting is happens. Where upcasting is happening. Observe carefully. When you are calling test method by supplying byte value, byte is going to be upcasted to short. While returning, we are returning what? Short value. Short is going to be upcasted to int. Then, while you are supplying this test method return value to the double, what happens here? Available is what? Return value of test method is what? Return type of test method is int. That int value is going to be converted to double. Upcasting, auto upcasting. Now, if you are trying to print a D, what happens? 10.0. Observe where and all upcasting is going to happen. At 3 places. While you are calling test method by supplying byte, it's going to upcast. While you are supplying this short value as a return type, as a return value to the test method, upcasting to the int. Then this value, test method, will be containing int value. That is going to be upcasted to double type, double value. 10 becomes 10.0. Observe this one. Here and all, casting is going to happen. Observe this one. Calling test one by supplying byte. So supplying is byte, accepting is what type? Integer type, auto casting. From byte to int. Now we are supplying the return value of test2 for the test1. So observe carefully. Test2 we are calling by supplying int and int both are compatible. Now while returning we are returning int, but here data type is what? Test2 test2 return type, long type. Int will be automatically upcasting the long. Now here long will be there. Long is going to be upcasted to float, long return value. That long return value is going to be upcasted to float. Now here float will be there. Test1 return value what? Float. That float is going to be auto upcasted to double. If you try to print it, you will get 10.0. Come to the next. Carefully observe where and all upcasting is going to happen. Test2 we are calling by supplying byte value. So both are compatible. Test2 argument is byte and we are supplying byte. Both are compatible. While returning, we are returning test1 return value. Now calling test1 by supplying byte value. Both are compatible. Calling test1 by supplying byte value. Test1 argument also byte type. Both are compatible. Now while returning value to the test1, we are returning what type? Byte type. But here test1 return type is what type? Short type. Byte is going to be auto upcasted to short type. Now test1 return value will be short type. That is short type is going to be supplying to test2. Test2 return type is what type? Float type. Short is going to be upcasted to float. Short is going to be upcasted to float. Here float will be there. That float is going to be upcasted to double. Syntactically proper. So whatever we have seen so far, auto upcasting, compiler only does that. There is no necessity of explicitly going for auto upcasting. We don't have to explicitly write the code For upcasting, upcasting always happens. There is a chance of upcasting. Automatically compiler only upcasting the required time. We don't need to write the code for that. But if still, if you want to write a code, this is how we can able to convert. This is how we can able to convert from one data type to another data type. What happens here? Int is going to be converted to double. That we are supplying to J. Before supplying to J, I we are converting I value we are converting to what? Double. 10 becomes 10.0. Then only we are supplying to J. In case of upcasting, it is automatic. Compiler only takes care internally. You don't have to worry about it. But still, if you want to write a code, this is the syntax. Syntactically proper. Byte b is equal to 10, int I is equal to b. Byte we are supplying to int. Autocasting here. Int j is equal to byte we are supplying to int. What we are doing first, we are converting to int. Then only we are supplying to int. First we are converting the byte we are supplying to int j. It is automatic. You don't have to explicitly write the code for this. For upcasting, compiler only takes care. Double t2 is equal to I. I is what type? Int type. So what we are doing, int we are upcasting to double. Then only we are supplying to d2. 10 becomes 10.0. Then only we are supplying that 10.0 to d2. So this one explicit upcasting. We can able to consider explicit upcasting. We are only doing the writing the code for upcasting, but it is unnecessary. Compiler only takes care. Internally, this is how it happens, but we are writing it down explicitly. But in this case, automatic. At line number 6, auto casting. You don't have to worry about that. Syntactically proper. So this is explicit upcasting. It's not necessary. By calling test one, first we are upcasting the int value I to the double type. Then only we are supplying that double value to test one. Explicit upcasting is unnecessary. Compiler only takes care internally. We don't have to write it explicitly. Syntactically proper. Calling test one. Inside test one, byte b is equal to 10. While returning, we are returning b, byte type. Will be automatically upcasted to int type. Now here int type will be there. That int type will be automatically upcasted to double. This is automatic. Explicitly, here we are calling test2. Observe carefully. First we are calling test2. Inside the test2, byte b is equal to 10. While returning, what we are doing? We are upcasting byte to the int type. Then only we are supplying to the test2. Then only we are returning the value to test2. Byte is going to be upcasted to int. The upcasted value we are supplying to as a return value to test2. Now test2 is having int return value. That int we are going to upcasting to double type like this. Then only we are going to supply that upcasted value 10.0 to D2. Syntactically proper. Carefully observe. You will get syntax error, compilation error, incompatible types, double cannot be converted to int, possibly loss of conversion, possibly loss of conversion from, possibly loss of conversion from double to int. See what happens. Int can only hold a number without decimal points. But what we are supplying? Double value. Double is having a number with a decimal point. So in this case, compiler won't be taking any risk. Where any data loss involves, where any data loss involving, compiler don't take any chances. There is a chance of data loss when you are trying to convert from double to int. Data loss. In this case, compiler won't take any risk. You will get syntax error for this. You're not able to convert from double to int. Possibly loss of conversion from double to int. Incompatible types. Possibly loss of conversion from double to int. See, see, basically what you're trying to do here, you're trying to downcast, not upcast, downcast. D1 is of double type. That double type you are trying to downcast to int type. In case of downcasting, it won't happen automatically. It won't happen automatically. Compiler doesn't take any chance in case of downcasting because there involves data loss. Data will be lost if you are trying to convert from larger range to the shorter range. So that's why compiler will throw you an error. This cannot be done. Incompatible types. there might be a possibility that you might lose some data. But still, if you want, but still, if you want, no, I don't care about data loss. I want to downcast. I want to convert from double to int. Yeah, go for explicit downcasting. Explicit downcasting. D1 double type. We are downcasting to int type. While downcasting, what happens? Int can only hold whole numbers. So what happens? That 0.9 will be gone. Data loss. 0.9 will be gone. Only 12 remains when you are trying to convert from double to int. That 0.9 value will be gone. Only 12. If you are trying to print I, you will get only 12, not 12.9. D1 is 12.9, but I will be only 12. Explicit downcasting. Syntactically proper because we are only doing the downcasting. I don't care about the data loss. I just want to convert. I just want to downcast from double to int. I don't care about data loss. Can run also. I value will get only 12, not 12.9. D1 value will be 12.9. I value will be 12. While downcasting, this 0.9 value will be gone. Observe. Test method we are calling by supplying byte type. Byte will be automatically converted to int. No problem at all. But then what we are doing? D1. D1 is what type? Double type. We are supplying D1 as an argument to the test method. But test method parameter argument is what type? Int type. If you say simply D1, you will get error, incompatible types. But we are only explicitly downcasting. Carefully observe. We are only explicitly downcasting D1 to the int type. While downcasting, what happens? That 0.8 value will be gone. Only 10 remains. That you are supplying to test method. First time you will get 10. Second time also will get 10. When you are downcasting from double to int type, that 0.8 value will be gone. 2 times. 2 times. Test colon 10. Then done. Calling test method by supplying double value 10.9. If you simply say 10.9, what it comes under? It comes under the value type of double. So both are compatible. Supplying double type, accepting also double type. But while returning the value, D1 is what type? Double type. But test method return type is what type? Int type. D1 is going to be downcasted to the int type. Then only we are supplying that value as a return value to the test method. Now test method contains int. Test method return value what type? Int type. That int type will be automatically upcasted to long type. Autocasting. Int will be automatically upcasted to long. See what happens here when you're going to lose that zero point 0.9 value at line number 5 while returning. You're going to downcast from double to int. That 10.9 is going to be converted to the int type. While converting into type, downcasting, that 0.9 will be gone. Only 10 remains. Now test method contains the return value 10. That is what type? Int type. That int type we are upcasting to long. Directly we are supplying, we are not explicitly writing the code for upcasting because compiler only takes care of upcasting internally automatically. So it will be automatically upcasted to long type. If you are trying to print LON, you will get what? 10. 10 you will get. Syntactically proper. Double downcasting to float, then float downcasting to int downcasting to byte. Explicit code for downcasting. Here what happens? Int I. Int I we are downcasting to byte. Carefully observe. Int I we are downcasting to byte type. Now byte will be automatically upcasted to short. Byte will be automatically upcasted to short type. First you are downcasting explicitly because compiler won't do downcasting. Int value we are downcasting to byte. Now compiler will convert this byte to short automatically internally. That is auto upcasting byte to short. Syntactically proper. Double downcasting to int. Int will be automatically upcasting to long. Carefully observe. Any number of conversion we can able to do. Any number of conversion. So D1 we are converting to double. Same type. Double. No issues. Value remains same. 10.99. So then float. Downcasting. When you are downcasting to long, carefully observe. When you are trying to downcasting to long, this 0.9090 value will be gone because long can only hold what whole numbers, not decimal point numbers. In this case, only you will lose this much of data 0.99. So it will be downcasting to int, short, byte. Then byte will be automatically upcasting to double. It becomes what 10.0. Now again you are downcasting to into type. That 0.0 value will be gone. Only 10 remains. So if you try to print I, you will get only 10. Syntactically proper. Only 10 you will get. Calling test method. Carefully observe. Calling test method inside the SOP. So what we are doing, double we are downcasting to byte. Byte will be byte we are what we are doing, we are only doing byte we are going to converting to short. Okay. Now while you are calling test method, you are supplying short value. D1 will be of short type. Now the test method argument is what type? Int type. Short will be automatically orchestrated to int type. While returning the value, return value to test method, I is what type? Int type. Int will be automatically orchestrated to double type. See here, when you are going to lose this 0.90 value, 0.90 value, when you are going to lose, that is here itself. When you are trying to downcasting to byte, here itself 0.90 will be gone. Only 10 will be there. That is 10 byte type. We are going to converting to short type. That is short value we are supplying to int. Int will be from short to int, auto upcasting. Short to int. Then here int value will be there. Int will be automatically upcasting to double type. When upcasting, what happens? 10 becomes 10.0. Now test method contains 10.0. That you are printing here. 10.0. 10.0. So this is how we can able to work with primitive number type of casting. Primitive number data type casting. So in the next class, we are going to see derived casting or reference casting. So please practice all these things. We'll continue tomorrow, same time. If you have any doubts, please ask. Fine. Please practice. We'll continue tomorrow.